In this video lecture, we're going to start to discuss about the artificial neural network. Okay, this is the outline of this first module, which is the introduction to artificial neural network. Okay, we will talk about the history behind the artificial neural network, or the motivation behind the neural network, and you can see over there that that is why we stress about the linear regression and logistic regression in the previous lectures, because you can see there, okay, linear regression and logistic regression is can be considered of the main component that actually started the artificial neural network. Okay, later you will see that, okay, artificial neural network is actually a standard version of doesn't matter is it a linear regression or logistic regression. And then the one that you might not familiar is this the second one, which is called as a Perceptron algorithms. And then we will talk about the neuron model, and then again we will stress on the gradient descent. Okay, we already give you some exposed to gradient descent in the previous lectures. Okay, that is very important to prepare yourself to get to know more detail about the gradient descent that happen in artificial neural network. And then we talk about the activation function, and I also, if we have some time, then I will give you some example on how to build your artificial neural network from scratch, okay, using MATLAB as well as in Python. Okay, when we talk about the history or the motivation behind the artificial neural network, and then you cannot deny that linear classifier or linear regression, sorry, this one should be linear regression. Okay, linear regression is one of the element that important in elements that make the neuroscience manage to model the neural network, which is mimic your neural network or biological neural network that operate into your brains. Okay, so if we talk about the linear regression, okay, this one have been discussed earlier. I don't want to discuss anymore. Okay, we already discussed about the linear regression. Just don't confuse with that equation there. In this one, I forget to change the notation. Okay, again, like I said, notation can be changed. It depend on what source that you refer. Okay, previously you always familiar with, instead of using a theta, you are using a beta. So this one should be your beta naught, and this one should be your beta 1. Okay, this one become beta naught, and then this one is beta 1, and this one everything shall become beta naught, beta 1, beta 2, and up to beta d. Okay, it's the same thing. And then that is a linear regression. And then I already stressed about the cost function. Okay, a cost function, if you see over here, we realize that cost functions, later you will see we are not always use the word cost function. Sometimes you can also call it as an error function or loss function. Okay, and then even the notification, later you will see it will change. Okay, instead of using J, okay, later we will use the notation as E. Okay, actually that's refer to the same thing, which is a cost function or loss function. And then this is one of the important element in ANN. Okay, before they develop artificial neural network. Okay, one of the earlier technique, or the one of the earlier trial to develop some computer that managed to to make a decision. They are introduced with some algorithm which is called a Perceptron algorithm. Okay, so a Perceptron algorithm, this is the old one, and this picture over here just show to you that this is a big computer, where this computer be able to learn and to classify the to recognize the letter of the alphabet. Okay, it will produce, you can see over here, it will produce 400, meaning that input image. Okay, the input of this learning machine or the Perceptron algorithm over here is the some image of your letter, and then that letter in size of 400 pixel image or 20 times 20, and it will keep learned, and that image actually represent many alphabets, and the computer will learn and recognize this alphabet based on the given image in the size of 20 times 20 pixels. Okay, so this is how the structure is look like if you talk about this perceptron algorithm. Okay, if you can see here, I think you might familiar with this behavior. Is actually is a one way to okay, if you remember, then we discussed about the basic optimization searching. Okay, basic searching for optimization. Okay, and then we discuss one of the things that we later will discover is or the common method to do optimization is what we call as a gradient descent, and the purpose is to update the beta. Okay, but here you can see that like I said before, previously we always use beta, and you realize that okay, this is also things that I will like to highlight. Later you will realize that previously you always deal with beta naught plus beta 1 x1 until your beta d xd, and when we discuss about the artificial neural network later, this notation will be changed. Okay, again, okay, it will be changed again, but don't get confused. The concept is similar. This is a linear equation, and then later you will realize that we are using this b naught will become b, which is represent bias, and the rest, okay, b1 up until bd here over here, I'm sorry, beta 1 up until beta d, we always use the notation which is we are change the notation from beta to w1 x1 to wd xd, which is represent the wake, and this one is bias. Okay, we will discuss this in detail later, but this is I don't want you to confuse with this one, because this is how we want to rename the notation so it become meaningful in artificial neural network. But here you will realize that the concept is similar. It's actually the fundamental of artificial neural network still is a linear regression and logistic regression. The difference is just you are changed the notation there from using the beta as a parameter. Now you are changing into two parameter, which is bias and wake. Okay, bias is your y-intercept, and the w1 or until wd, then that will become your slope. Okay, so it's the same things there. And then if you realize over here, there's a mechanism of update the w or update the beta. Okay, update the parameter updater, but they are not using the concept of gradient descent. Okay, they are using the base the some kind of mechanism which is not gradient descent, but it's you still can see that the mechanism of this iterative behavior is seem to be is a concept of a basic searching optimization approach. Okay, but it's not using the gradient descent, but it keep updating the w there. But the things that I really to highlight over here, the perceptron algorithm, you realize that this is how the equation is look like. You can see that this is your linear equation. Okay, because this one is a dot product. Actually, this is a linear equation, your linear equation, and this is actually your f1. If you remember, we talk about the f1, and then the whole thing over here, yeah, is actually your f2. So if we try to relate with our previous discussion, if you remember our previous discussion regarding this pictures, so later I will tell you why I so interested in represent all the system, all the function in this all the system in this cascading two function. Okay, because that is this thing is very important fundamentals concept that happen in your neurons. Okay, or your artificial neural network. Okay, you realize that you have learned so far, this is your linear, this is your linear, this is your logistic, and this is your softmax. If you talk about the previous perceptron algorithm, you can also represent in this form. It consists of two functions. Again, this is your linear function. Okay, this is the same linear function. You realize that doesn't matter which system f1 is always in linear equation or linear function. Okay, and then the one that you change is your f2. Okay, if you talk about the perceptron algorithm, the f2 that you use in this f2 is known as a unit step function. So how is the unit step function look like? Is look like this one. Okay, if you remember about the unit step function that you learned in, I believe you learned in signal and system, it's a same function that you learned before in signal and system. So it's a unit step function, meaning that if the input is negative, it becomes 0. If the input is positive, it will make the output become 1. So if you set your f2 with unit step function over here, and you are using f1 as a linear function, is actually you are developing a perceptron algorithm, okay, which is same as this one. Okay, so that is the perceptron algorithm. And then one of the disadvantage of the perceptron algorithm is you can see through this function, because f2 is always some kind of non-linear function for the purpose of decision making. You can see that now your function here, since you are using unit step function, now the output here is a same as, okay, the function, the output over here is a categorical output, meaning it can be either 0 or 1, as a class 0 or 1, meaning that this perceptron algorithm will become a classifier. Okay, but you can see that the decision of, we can see that because the decision to decide whether that the output is 1 or 0 is a kind of hard decision making, okay, because it can be either 0 or 1. So that's why this should be not good. So that's why they try to improve this perceptron algorithm. Instead of using a perceptron algorithm, they try to change, okay, instead of using a unit step function at this f2, okay, they are changing it into sigmoid function. So how the sigmoid function look like? Okay, if you remember the sigmoid, this is how the sigmoid look like. Okay, sigmoid is something like this. Okay, so you can see that sigmoid function is, this one is 1, this one is 0, but the decision or the transition here, okay, you have a some value, okay, not just hard decision making like this. This one is very hard decision making. It's a hard decision making. It's either 0 or 1. But for sigmoid function, you have soft decision making. You at this transition, you can say that if your v is at this position, then you can say that the decision is more heavy towards 0. If the v over here is at this side, you can say that your decision is more heavy to 1. Okay, it's not 1. Okay, it's more heavy to 1. So it's a kind of soft decision. Okay, soft decision making. Okay, decision making. This one is hard decision making. So that is the history of the evolution of this classification or linear regression. You can see that instead of the disadvantage of perceptron algorithm, it consists of hard decision making. So that's why from time to time you can from time to time they try to improve the perceptron algorithm. Instead of using f2 as a as a unit step function, they are changing it into a sigmoid function. And then once this f2 become a sigmoid function, it is not called a perceptron algorithm anymore. It's called as our logistic regression, which is this one. So that is where the logistic regression come from. If you discuss about the history behind the artificial neural network. But okay, let's go back to this part. Okay, that is how the history begin. You can see that once the linear perceptron algorithm disadvantage is because of the hard decision making, they introduce with what we call as logistic regression, where it improve in term of replacing the hard decision making into soft decision making. So that is the one things, but still doesn't matter is it a linear perceptron algorithm or logistic regression. One things that for sure they both have the same disadvantage, because they both have the same disadvantage, which is it's only can generate the boundary or the hyperplane if the input between class A and class B is well separate, like in these pictures. Okay, but if you, let's say, if you have something in this condition, let's say this is the condition where you have red dot over here, then regardless of whether you are using the perceptron algorithm or logistic regression, they are incapable to classify this condition, because now you have is not well separate, because this region also you will have a red point or red data. Okay, meaning that you need to generate two boundaries instead of one boundary. So that is the limitation of both perceptron algorithm and logistic algorithm. Okay, the rest regarding the logistic regression, this one I already discussed previously. Okay, you can see that this one is known as, if you talk about, okay, you can see that now we are not using J anymore. Now it's become E. Actually, it's the same thing, cost function or loss function or error function, but this one is actually your MSE, because you have a 1 over n. You are using MSE. But again, like I mentioned previously, instead of, if you talk about the logistic regression, because logistic regression is the classification model, so instead of using MSE, you can also use this cost function. Okay, this is known as the one that I mentioned before, which is your entropy. Okay, if you remember that one, okay, it's a cross entropy. Okay, that one is a cross entropy. So but I don't want to discuss that one in details. Okay, now let's discuss about the biological neuron. Okay, this is the biological neuron in our brain, consists of dendrite, axon, and synapse. Okay, you can see that the dendrite will receive the electrical signal from the other side, from the input side, and then the axon here will pass the impulse from this dendrite there. Okay, you can see that the dendrite will receive multiple input electrical signal from this line, and then once your neuron over here will activate. Okay, it can be activate, it can't not activate. It depend on which things that you do. Okay, it depend on because in your brain there's a lot of neuron, and if you behave in different way, you see that some neuron will activate, some neuron will not activate. So if this is where it happen inside this neuron. Okay, it can be activate or not, or it can be firing or not. If the neuron is activate, it will send the impulse or the electrical signal to this axon, and it will pass to all the synapse, and this synapse is actually will connected to the next dendrites. Okay, dendrite of the neighbor neuron. So that's how it's work. Okay, as you can see in this animation, if the electrical signal going to this center or the nucleus over here, okay, it will activate. It will firing the signals to the next neuron through the axon and to the synapse. Okay, again, imagine if you talk about the several neuron, or we call as a neural network over here, biological neural network over here. Okay, if you give a stimulus or the electrical signal, it will send the impulse. If this one is trigger, it will send the electrical signal, it will send the impulse to the next neuron through this this one, which is the synapse. Okay, it will send to the synapse, and the next neuron through the dendrites will receive that signal. So that's how it's work, meaning that there's a mechanism of the inputs going to the nucleus, and then that nucleus will later your neuron will decide whether whether you want to firing the signals to the next neuron or not. Okay, that's how the when the neuroscience observe the behavior of your brain. If you do certain activity, certain neuron will activate. If you did, or you do a different activity, certain neuron will activate. It depend. Okay, it will decide based on certain pattern, meaning that some will activate. Okay, if you talk about activity A, this set of neuron will activate. If you do the activity B, another set of neuron will activate. So that's mean in one cell, in one neuron, it behave in two things. One is depend on the input or the stimulus from the input side, and then from there your neuron will see whether this one should be triggered or not, whether this one should be transferred to the next neuron or not, through the axon, based on whether we want to activate or firing to the next point or not. Okay, so based on that, the neuroscience try to model this singles neuron to the mathematical equation. So they find out, okay, you can simplify the behavior by using this model. Okay, you can see this is your this is the electrical signals. Okay, the electrical signal is your x0, x1 and x2, and then it will go through your synapse. Okay, this is the synapse of the previous neuron, and then this synapse is actually should have some wake. Okay, this W over here is represent your wake, where it's like controlling the which line over here, which arrow over here will give some major information or minor information. If the wake over here is high, then means that this x1 is very important as compared to this one. If you talk about if W not over here is small, so meaning that you must have some wake which can control which signal is important to be go inside this cell body. Okay, and then from there they find out, okay, this one can be represented by some linear equation. Okay, and then again, like I said, in this previous one, you can see that another behavior about your neuron is that it can be activate. Okay, means that once the stimulus is strong enough, it will stimulate and firing the signal to the next neuron. So that's why from the perspective of neuroscience, it said that instead of there's some a linear function, they also have some other function where that function will the purpose of that function is to trigger or to firing when you have a lot of when you have enough energy to stimulate or to firing the signal to the next neuron. So that's why from here they try to model, and they find out that, okay, actually in one neuron or one node over here actually is consists of two function, which is known as, okay, the one function is known as an input function. Okay, this is known as an input function, where the relation between the input function and the input as input, which is x0, x1, x2, is a linear relation. Okay, that's why we have a summation plus the bias. Okay, the one bias should be, okay, B over here is a bias. Okay, it's another line there, there's a B there, bias. Okay, and then by having this linear function, okay, it's not enough to represent your neuron, because your neuron also consists of some activation behavior or some firing behavior or trigger behavior when the signals come from the input is strong enough, and it will firing to the next neuron. So that's why they come up with another function, which is, this is also known as activation function. Okay, where the activation function is like a switch. When the strength of the input is high enough to trigger to certain where it will achieve to a certain threshold, meaning that where it's increase more than certain threshold, then it will firing the signals to the next neurons. Okay, so that's how it's work. So from here, as you can see that this is how the mathematician or the the neuroscience models the single node or single neuron. Okay, this one is considered as your neurons, single neuron, or some books they call it as a node. Okay, so it consists of two functions. So how does this one relate with the previous lecture? So let's go to our whiteboard here. Okay, you can see that. Remember that I always interested to draw our system in these two function. Okay, I draw it when I draw a linear regression. I said it can be drawn in two function. Okay, this one the difference is that this one is a linear, this one is the one that you always change, and when you change this one, it will also change the name of the system. Okay, if you use the identity function, it become linear regression. If you are using the sigmoid function, it become logistic regression, and if you are using the softmax function, it become softmax regression. So then if you are using a unit step function, it will become a perceptron algorithms. So from here, actually this is what we call, okay, by combining or cascading two function, is look like your single neuron. Okay, if you see, I just in this slide or in this whiteboard, you can see in this figure, this is our system. The same system consists of F1 and F2. Just realize that this one should be, okay, this one is bool, it's bool. Okay, bool means that I can also draw in this way. You have x0, x1, x2 until xd. So to simplify, that's why I use a one line. I draw it in bool. Okay, so it's represent the vector. Then I can, by having these two function, I can also make it okay, to have some relation with our single neuron that we have discussed before, where we can see that again this is the previous neuron or node, single node. You can see it consists of two function. One is input function. Okay, this is known as an input function. Okay, I've write here input function, where actually that is your F1, and this is F over here is called activation function, the one that firing the signal to the next neuron. Okay, this is actually your F2. So in other words, that is the reason why I always stress on this, for each and every system is consists of two function, because at artificial neural network, a single neuron actually consists of two function. One is known as input function, that is your F1, and another one is your activation function that is notated with F over here. Okay, so again, this one is similar to the previous one. This one is always linear function, come from the linear regression, and this one can be changed. You can use the activation function over here, can be changed. You can use a unit step function, you can use a sigmoid function. So it's for artificial neural network is free for you. You can use any activation function that you want. Okay, but there's a disadvantage and advantage. Which one you want to choose in order for you to set your activation function. But at the end, you can see that one single neuron, imagine that one single neuron is actually consists of two function, where in other words, one single neuron, if your activation function is your sigmoid function, then that one single neuron is look like logistic regression. So imagine if you cascade many neuron or many neuron, meaning that you have a bunch or a lot, several regression function that is cascade together. Okay, then that one, if you assume that your activation function is a sigmoid function, so meaning that neural network is more than that simply more than just a simple logistic regression, because you are combine several logistic regression together to perform or to solve a big system that can be solved multi-class, and you can also solve many condition that that is not capable to be compute or with your logistic regression. So and then in some textbook you will realize that they also use the same thing, the same picture like this one, but they are drawing in this way. Okay, they don't call F1 and F2, they always use this symbol, meaning that this one is your input function, this one is the activation function. They use the symbol summation here because this one is a linear linear equation, and linear equation can be represented by using that summation symbol. So that's why they are use a summation here to represent your summation symbol. Okay, you realize that the notation here is okay. Another things that you need to remember, now the notation is changed. Okay, instead of using beta, now your beta naught become B, which is bias. Beta 1 to beta D will become W1, W2, W3 up until WD. Okay, that's how they represent the notation in artificial neural network. Okay, this one again you can change, is up to which activation function you can change your activation function. But in this artificial neural network module, in general we always use a seed mod function here. Okay,